Let's go ahead and take a look at a couple of properties of derivatives. We've previously looked at about 9 rules when it came down to the derivatives of some simple functions. Today we're going to go ahead and take a look at the continuation of those properties of derivatives. Most likely get introduced to some trig functions derivatives. So let's start with number 10. Y is equal to the sinus of u. U being a function. In order to take the derivative of a sinus function, all you have to do is essentially write it as y prime is equal to, y prime indicating the derivative symbol. So y prime is simply equal to u prime times the cosinus of u. So for example, if you're taking the derivative of a function like y equals to the sinus of 2x, you simply have to write this as y prime is simply the derivative of 2x, which is the function u. The derivative of 2x is simply 2. If you have missed out on the last couple of videos about how to take the functions of something like 2x, watch my previous videos. But anyways, the derivative of the function u here, 2x, would be 2 times cosinus of the same function again. Rule number 11. Let's say we're supposed to take the derivative of a function like cosinus of u. So y is equal to the cosinus of u. So what you have to do here in this scenario is you have to kind of just say y prime again, which is the derivative of this function, and it's going to be equal to negative u prime sinus of u. So basically, the cosinus changes to sinus, and you just get negative u prime. So as an example, you could be given something like basically y is equal to cosinus of 3x. The derivative of this function would simply be y prime negative 3 sinus of 3x. That's it. Let's go ahead and continue now. So rule number 12. For rule number 12, we could take a look at the derivative of the function y equals to tangent of u. For taking the derivative of the tangent of u, we could look at it in a couple of ways, but the basic general formula is the derivative of this function, or y prime of this function, is simply u prime times secant square times u. Or you could also write it as u prime times 1 plus tangent square u. Or you could also write it as u prime times 1 over cosinus square of u, because we know that all of these ways of writing are possible because of the trigonometric formulas we've learned before in our trigonometry courses. So for example, if you were to ask to find the derivative of the function y equals to the tangent of 7x, you can take the derivative of this function by simply using any of these three ways. So you can write it as y prime is equal to derivative of 7x would simply be 7. So 7 times secant square of 7x. Or you can write it as 7 times 1 plus tangent square of 7x. So all of these ways are possible, and even the third way. Let's go ahead and take a look at the next rule now, rule number 12. Let's say you're supposed to find the derivative of a function like y equals to the cotangent of u. So in order to take the derivative of cotangent, you just simply write this as y prime is equal to negative u prime times cosecant square of u. So you can write it as the cosecant of 2 to the power of 2, or you can write it as all the other ways you can write cosecant, because we know that we can now write it as negative u prime. Cosecant 2 squared could also be written down as 1 plus cotangent square u, or you can even write it as y prime is equal to negative u prime times 1 over sinus square of u. So there's three ways you can write the derivative formula for cotangent because of the application of the trigonometric formulas that you know. Now, in order to take the derivative of such a function, for example, let's say you have y is equal to the cotangent of 3x plus 1. In order to take the derivative of this, y prime is simply going to be, you take the derivative of u, which is just u prime, But since it's negative u prime, you got to write negative 3x, negative 3, plus 1, plus the derivative of 1, which is just 0. So just negative 3 times by cosecant square of the original function, which is 3x plus 1. And of course, you can write it using any of the other two rules, either this one, the one with the blue arrow, or the one beneath it, negative u prime times 1 over sine square of u. Let's move on and take a look at the next property now, rule number 14. So last one was about cotangent, and this was supposed to be rule number 13, by the way, because we learned about the 12th before this. So rule number 14 would be the derivative of y equals to secant of u. In order to take the derivative of the secant, we simply use the formula y prime is equal to u prime times secant of u times the tangent of u. So if you have a function like, for example, the secant of 5x squared, the derivative of this function is going to look like this. Y prime is going to be the derivative of u, and we know that u prime is simply going to be the derivative of 5x squared, and using the rules of derivation for that, we know that it's going to be 10x, because we have to subtract 1 from the power of x and then multiply the power of x by 5. So that gives us 10x. So 10x times the secant of 5x squared times by the tangent of 5x squared. That would be the derivative of this function. Now, in order to take a look at the next rule, let's consider the friendly neighbor of secant, which would be cosecant. So in order to take the derivative of cosecant of u, you just have to write it as y prime is going to be negative u prime times the cosecant of u times by the cotangent of u. U, of course, being the f of x, or the function. So basically here, the derivative is going to be looking like something like this. So for example, if you have y equals to the cosecant of 3x squared plus 2x, you can simply find the derivative of this function by considering this to be u. U prime here is going to be 6x plus 2. So since it's negative u prime, y prime of this function, or the derivative of this function, is going to be negative 6x plus 2 times the cosecant of 3x squared plus 2x times by the cotangent of 3x squared plus 2x. And that's it. That would be the derivative of a cosecant function. Now, up there, when I was talking about the derivatives of the tangent and cotangent function, I assumed that you will remember some of the trig rules that I used over there for the simplification of the derivatives. You don't really have to memorize all the 3 rules. All you have to do is remember the trig ratios you've learned before and the trig formulas. So this is a quick note if you have forgotten. We know that the secant square of a function u is going to be equal to 1 over cosinus square of u, or equal to 1 plus tangent square of u. And that's why those 3 formulas were kind of equivalent to secant square of u, because we know that also secant of u is simply the inverse of the cosine of that function. The same thing exists for the cosecant square of u. We know that cosecant square is technically 1 over sinus square of u, and also equal to 1 plus cotangent square of u. So this is basically a simple rule that you should remember from trigonometry. We also know that cosecant of u is simply 1 over the sinus of u. So these are 2 rules that we should have remembered from trigonometry, and I thought you should remember this. So that's it for today. We've got 15 rules so far. Stay tuned for the other parts of calculus, and make sure you practice. Goodbye and good luck.